exciting parts. The lightning talks. This is where we get to actually get a chance to see what people have been doing that may have done something actually maybe over the last 24 hours, 48 hours, and go through some really cool things that have been happening recently. We have, I think, 4 lightning talks for this afternoon. The first one up is Alex. He works with me at Relevance. Has the most excellent mohawk on the planet, that I think might is a kill kind of thing. Awesome. Dead animal hawk. So, Alex.
All right. I'm Love Machine. I like ideas. I like ideas because they're something that we kind of share a relationship with. Humans can use ideas, but ideas can also use humans. One way that an idea can be using a human is that an idea can take up residence in your mind. It can burrow in and hang out there for years and years. And another way that an idea can use a human is that we can communicate them to each other. And in that manner, the ideas are using us as replicators for themselves. I'd like to talk to you about one of my ideas, which is on Cyclic Time. A long time ago, I had a problem where I had to write a scheduling mechanism. I think that there's probably a lot of people in the room who've had to do this, but Cyclic Time is a problem that solves a lot of problems. Or it's an idea that solves a lot of problems, right? It allows you to do scheduling. It allows you to do calendaring applications. It allows you to do billing. There's applications for this idea of cyclic time. And it's an idea that if you can pull it out and treat it abstractly, you can start building things for solving all of these problems on top of that idea. So I'd like to do a little bit of an audience participation session. Real quick, just by show of hands, who here has ever had to deal with a scheduling problem? All right, great. Now, who here looked at cron and said, man, I really don't want to use that because it looks ugly? All right. Of those, who decided, you know what, I'm going to do something different than cron. I'm going to do something better than cron. Who succeeded? Okay, good. I'm right there with you. About 7 years ago, I had the idea of, I wanted to beat this problem, and I surrendered. But about a couple months ago, a gentleman named Alan Dipert, who I work with, was talking about this idea of cyclic time with me. And I was revisiting my ideas about cyclic time. When I first tried to solve this problem, I didn't have a good solution. And I think a lot of the reason I didn't come to the right solution is I didn't have the right tools. When we started thinking about it again, I'd been educated in Clojure, and I was able to start using the tools that Clojure provides to apply them to this problem. And I came up with something that, it's an interesting idea. I haven't been putting it into production, I haven't been using it in anger, but it's a scratch that's looking for an itch. When I'm thinking about cyclic time, I like to think about it in these kinds of terms. Time is a single dimension. It's uncountably infinite. There are infinitely many instances in time. And that's not useful. We can't work with an uncountably infinite set of time. And the final quality of time that I like to think about when I'm working with this problem is that we tend to break time into ranges. Ranges between one instant and another instant in time. This is useful. This is a useful way to abstract over units of time, such as seconds, minutes, hours, years, millennia. They're all just points between one instant and another instant in time. So when I was wanting to work with time, and when I was discussing the idea with Alan, there's really only 2 things that I want to be concerned with when I'm trying to conceive of cyclic time. Periods. It's a range between 2 instants. And if we agree upon a convention for expressing a period of time, in my library, I'm using the convention of a vector that has a start point and an end point, and that's it. And the idea of cycles, which are repetitive periods. You can think of cycles as being a generator that would create multiple periods that are self-similar. And the real problem with time, I think, is in these cycles, because most cycles are pretty simple, right? Seconds are uniform. No second is different from another second in terms of the actual span of time it's tracing out. This holds true all the way up through weeks, but when we start getting into months, months get really kind of fuzzy. They're a nasty special case if we're talking about months the way that humans talk about months, because February has 28 days. each month has a very slightly different duration, and that makes it a little bit complex. But there's a nice little cheat that you can do. It's called using Java Util Calendar, which handles all the logic for you. And that's basically what I did, is I built up this idea of cycles and periods on top of Java Util Calendar, and I called it Monotony. There's not a whole lot to it right now. I think the main points are one function I call it periods, and you hand it a keyword saying, what do you want the cycle period to be? And it will return you an infinite lazy sequence of periods, just these vectors of 2 instants, such that they dovetail nicely, and it starts with the instant that you call the function by default. You can reconfigure it. But it generates this infinite sequence, and now you have a cyclic generator. And the other, I think, important tool here is bounded cycles in this example, I would like you to indulge me and pretend that November was bound to a vector that included the first instant of the month of November and the last instant of the month of November. And what bounded cycles does is it breaks down that month of November into another series of periods at the resolution of days. We've now got a sequence of all the days in November represented using periods. And we can start doing computation based on what days are important. The example I use in the README for this library is to try and generate all of the Clojure meetings that Relevance holds at Relevance headquarters. They occur on the third Wednesday of every single month at 6 p.m. And the way that I basically go through this process is decompose a month into days. I have some predicate functions so that we can examine whether a day is Wednesday. So we filter all the days down to only the Wednesdays, pluck the third one out of there, find all the hours in that day, pluck out 6 p.m., and now we've got the period for when the Clojure meeting is going to be occurring. I think this is a useful way to think about recurring cyclic time, but it's also an immature idea. I haven't spent a whole lot of time working on it. But these are the kind of tools I had to use to build up to this point. One of them is retrieving our concepts of what are natural boundaries. You can use, there are many, many milliseconds out there that are not cleanly on the boundary of, the instant when we change from Tuesday to Wednesday, for example. It's useful to be able to find these cut points and to specify periods relative to any arbitrary millisecond within that period. We have predicates for testing human names for things like, the Wednesday in some week, or is this month July? And, sorry. And we can, in the library, consume either dates or longs interchangeably, the convention being that we basically shove longs into dates or hold the milliseconds off dates. And that's basically my, I just wanted to introduce this concept to you and get you thinking about it. I'd like to invite you to play with Monotony. I have it on GitHub, and you can add it. It's also pushed out to Clojure, so if you're interested, you could add it to your project and start playing with it. If you'd like to fork the work, submit pull requests, or report issues on the library, I'd be very appreciative of it. But finally, the last thing I'd like to invite you to do is to go digging through your old ideas in the past. Particularly, if you've had a problem in the past that's defeated you, you surrendered to, and use what you've learned working with Clojure to try playing with it again. Think about what kind of new solutions you can find by using the toolbox that Clojure gives you. In my particular case, the idea of lazy sequences was incredibly useful for tackling this problem. And I think that if you revisit some of your old problems, you might also find some really good solutions in the Clojure toolbox that help you solve those problems. Thank you.
So next up, we have a really interesting treat. There is a new thing that has entered the world with the name of Immutant, and I don't know what that clicking is. Okay. Anyways, there has been some really interesting work recently done in just tying together application servers and new ways of deploying your Clojure code and actually allowing you to interact with other non-Clojure code. And I think there's a whole bunch of really cool stuff that can happen here, and kind of marrying Clojure and legacy code and things like that. So I'm going to let Jim take it further and talk to you about Immutant.
All right. Can you hear me? Good volume? Good. All right. So, Immutant, an application server for Clojure. I'm sure that frightens some of you, possibly. So let's try to allay some of those fears. Because we are new to the community, let me introduce myself. I'm Jim Crossley, Toby Crawley. We work for Red Hat. We are core committers on TorqueBox, which is, if you hadn't heard of TorqueBox, TorqueBox is an application server for Ruby. Both TorqueBox and Immutant are enabled by the JBoss AS7 Java application server. Now, so application server basically means middleware. Middleware is the accidental complexity. It's all the software you build or configure or use that doesn't have anything to do with the problem domain that the application you're trying to build is trying to solve. So an application server done well is basically a clean-shaven yak. And that's what we're trying to do. It is very easy to do an application server poorly, and we have failed if we do that. So even though I just said that, clean-shaven yak, what does that mean? What is an application server? It is perfectly correct to think of JBoss just as you would Jetty or Tomcat. So just as you would use Redington to bring up Jetty to run your ring-based application, you do the exact same thing with JBoss. But in addition to that, you get other services. It's an integrated, all-in-the-tin solution. We provide, in addition to the web, messaging, caching, messaging through Hornet Queue, JMS message queue, caching through InfiniSpan, which is a key value store, data grid, all kind, easily replicated service. Clustering, we get into all the standard things that you would expect to see in the E word. So, to get all the advantages of those services, traditionally, you've had to assemble a big pile of annotated Java classes in XML. So, TorqueBox was written in response to that, to say, none of that. We do all Ruby. Where, we've talked about wrapping as an overloaded term, but we are wrapping with malice. We are opinionated wrapping. We're not just exposing those Java services via JRuby. We are adopting that policy or embracing that notion of configuration, convention over configuration. And JRuby basically enables us to be the fastest platform for any kind of Ruby web app development that's out there. You can Google for TorqueBox benchmarks to see that for yourself. So basically we're just replacing Java and XML with Ruby and YAML, and we're very excited we've got a new version come out. So none of that you're interested in. We've only talked about Java and Ruby so far. Let's get to the Clojure. TorqueBox inspired the idea of Immutant. So essentially it's a DSL to describe the middleware that your application would need. DSL in its most loose definition. So far, we've only been doing this for a couple of months, and so far we have web and core messaging stuff implemented. Because we're an app server, you typically deploy multiple applications to it, so you want some isolation. We have that working. We're trying to make it all installable, runnable, deployable using a Redington plugin as well. So here's a quick example. You're just writing your project as you normally would in Redington, but when you deploy it to Immutant is looking for a top-level Immutant CLJ file. Here's an example of how we might, this is a messaging and web namespace. Here's how we're starting, just starting a queue, and we are mapping a handler to receive messages that are posted to that queue. And I'm going to pause for a moment while each of you say in your mind the name of that function, the name of that handler. So this is Ruby development. You know, we do feed jokes. All right, so ring handler. Here's the, we support any kind of ring-based web framework that there is. This is a simple handler where we're just going to publish to our work queue any composite data structure we'd like. It just has to be understandable by whoever's going to receive it on the other end. If it's another Clojure app, great. We're just print duping that stuff there. And you associate that handler with a particular web context. Just your typical way you would do that with Jetty or Contact. So that's what we have working now. But we also have a vision for the future because we're kind of, JBoss is embracing this notion of Polyglot. In other words, use the best framework available on the JVM regardless of what application it's written in. So a lot of people have expertise in using Ruby on the website. We want to let them do that. There are great analytics packages. In Clojure, we like to allow them to easily exchange messages between both of those producers and consumers. Currently, we do that using JSON encoding, but we'd love to do the Ruby side of those tag-based serialization stuff that Rich talked about yesterday to further that. So, interlanguage messaging, uniform deployment, you're always deploying it the same way. An integrated stack, you're not building up your stack every time. And we get very simple horizontal scaling just based on JBoss's built-in clustering capabilities to where you automatically, just by using a different command line option, you get automatic load balancing across a cluster of immutants of the consumers of those messages that you might be putting on whatever JMS destinations there are. So, we are new. We love the help. We're all open source, either by helping us build it or kind of pulling us in a direction that makes sense for your organization. Freenode's the best place to contact us, or we have a contact points at Immutant.org. That's basically all I got.
So the next set of presenters, I guess people all know the term hipster. These guys are Lispsters. You can say that 10 times fast and make your brain explode. So these guys thought that Clojure was cool, but they want to do something cooler. And so Alan and John are going to talk to you about Uberlisp.
So quick show of hands, who's familiar with something called the Arduino? Oh, wow. Okay. So for the two people that haven't seen it, it's a microcontroller. It's a microcontroller like many others with capabilities similar to many other microcontrollers like the PIC or other things. And microcontroller means really small computer, effectively. The differentiator of this thing is that they're cheap. The cheapest one you can get is about $10 for a kit. The other thing about them is they have easily accessible I/O. So if you're ever trying to do any kind of I/O between your computer and, say, your toaster, there's not like a USB doodad that's going to do that for you. That's like you figuring out the USB thingy and like going nuts. The Arduino has rows of pins. You plug wires in, and you can programmatically turn those things on and off with registers. So it's a great little platform for doing prototyping devices that do physical or electrical interactions with things. There's a huge hobby community around these things. People are making their own garage door openers and alarm clocks and all kinds of other really mission critical useful things. So I got into this thing a couple years ago, and I bought all the gear, and then it was on a shelf for a couple more years, and pulled it out recently because I wanted to make some Cylon lights for my pumpkins around Halloween. Which is something you can totally do, and it's pretty straightforward. But here's the pickle: you can't do it in Lisp. And I think we all know, as people who are just obsessed with Lisp and sort of can look at other things and be like, yeah, I really miss Lisp. It's kind of cool that you can do this thing, but it's not Lisp. So I had this idea to write a Lisp that would run on the Arduino, so that I could do the same kind of interactive, real-time development on a microcontroller that I'm used to at a Clojure REPL. I wasn't sure if it was possible, but I started anyway. List from the bottom, if you haven't done it, implemented it, I think it's Paul Graham who talks about there's these two things that are high ground, C on one end and Lisp on the other. It's actually a really cool exercise to kind of start at one end, and then you kind of wade through the morass, and then you kind of get closer to the Lisp side, and you can start to see the sky again, and then you have a Lisp. So if you haven't made your own Lisp, I really recommend it. As far as the rationale for doing it, conspicuously on the Clojure.org website, on the rationale, Rich says, I needed it for functional programming, all these things, and then I needed a Lisp with no further justification. So this truth is self-evident. Just go nuts. Doesn't matter if there's a problem to solve. The fact that you haven't written your own Lisp is the real problem. So without further ado, John's going to do a little demo here. Quick tech specs and highlights. So this thing has 2K of RAM. That's almost 15 tweets worth of information. We've got lexical scope, first-class functions, all these things that we know and love. And thanks to John's help, it all kind of works. I told him about this idea in the morning after I saw I got 10 emails between the hours of midnight and 5 a.m. and a workday. He's done a lot with figuring out how exactly these ideas map to the lower level things, like reading specs and data sheets, and he's kind of the wizard between how it actually works. My initial pass was garbage and was collected. Anyway, I'm going to mic up John and kind of stand around, and he will interact with this thing at the REPL.
You guys hear me?
Hello?
Hello. Microphone works. So this thing's written in C. Don't need to show you the source code right now, but it's plugged in. We wrote some make tasks that build and flash the Arduino. So we're going to clean, flash. Let's see. I'm running this on a Duo Milano because I like the USB to serial thing better than the one on the Uno. The Uno actually is a real pain to deal with. So here we go. It's flashing. It got really big yesterday when I included the delay library. I don't know why. Figure that out tomorrow. So here we go. Or tonight. I got some debug output. We basically got a REPL. Now you can see at the top we've defined all of those symbols to be themselves because those are special. And since we're in Uberlisp, don't have to type anything. We're going to show you some exciting things. Let's see. So, come on, really? All right, I'm typing. So we're going to def x as 1, 2, 3. Def y.
No GC either yet, so we can't type in very much stuff. Yeah.
Yeah, notice the memory used is, anyway, eval y. Bam. Wait, what did you do?
That's according to the value, same thing. got to get it right.
Okay. Well, that works. Emacs is the problem. I'm just going with that. And then y, we get 2. We can say let x be foo bar, eval y. We get bar, and we'll do blank.
Yeah.
All right, so I gotta type this real slow. Pooling. Okay, so set register port B 255. Sleep 100. Set register port B 0. Sleep 100. Okay, and then we have to set DDRB to 255. So now, blank. Look, it's not sleeping 100 milliseconds. I don't know why it's so slow, but it should be blinking.
Lisp is slow.
Is it blinking?
So I think that's anything you want to add, John?
Question?
Do you have a trampoline?
No.
Okay, so that's going to overflow eventually then.
Oh, absolutely.
But way after we're done, so.
Yeah.
Do some useful work.
Yeah, I don't know. Any questions?
Yes.
Does the thing actually do any case folding, or is that the reason why you type everything in caps?
Yeah.
Well, okay. So
That's a whole thing.
4 bytes for symbols, which means if your symbols are 4 characters or fewer, they're just the characters literally in a row, except that we set the high bit on the 4th character to 1, so that you know you're looking at a 4-character symbol. For up to 6 characters, you can use any characters A to Z and any non-A to Z character that automatically becomes underscore. Condensed down to 5 bits and sort of crammed into the 4 bytes, and then decompressed at the other end. So yeah, only capital letters, because lowercase letters are too big.
Oh, and I guess I had 2 small things to add. One is that the IBM 704, which is the first thing John McCarthy and Steve Russell did Lisp on, had about 32K of RAM. So, ha. The other thing is, since this is a very simple Lisp implementation, and we're very humble guys, we called it Uberlisp. And you can Google for it, it'll pop up, it's on the GitHub. Next big thing is GC, so if you have the chops, come on down. Let's compute. So thanks, everybody.
I'm looking for a Chris Granger. Oh, there he is. So our next lightning talk presenter is, I think, a machine. I'm not sure if he actually sleeps or not, but he has been just sending out libraries for us all to use Noir, Pinot, and now something just recently for SQL that I will let Chris tell you a little bit more about.
All right, yeah, so I'm Chris Granger, like you said, and I recently started working on a project that required a lot of SQL work. And one of the things that I had done previously when I had written frameworks actually in PHP was I wrote an ORM. And as I did that, I realized, hey, you know, ORMs are kind of cool, they seem nice, but it turns out that ORMs in the long run end up actually being kind of problematic. You end up fighting against them. You end up needing to do more than their abstraction allows you to do. And so what I wanted to do was work with a really nice abstraction for SQL on Clojure. And so this is kind of what Korma looks like. You define a database. Can everyone see that out of curiosity? You define a database. You know, I give a set of really simple helpers to create sort of these maps that represent your database connections, right? And under the covers here, I wanted to make sure that you don't have to think about some things that you would otherwise have to think about if you were using just straight Java JDBC. Things like connection pooling, as an example, right? You know, one of the things that I didn't realize when I started using JDBC was that I was going to have to manage that connection explicitly. So this uses a library called C3PO that does all that connection pooling for you. So you just start writing queries. And what you can see here is I have a thing called def entity. This is something that just maps directly to a table, more or less, but allows you to specify, you know, some properties of these things so you can do interesting things with them later. So, for example, I have a query here where I want to select, you know, all my users with their addresses. Since I've defined a relationship between my entities, I can do that. And on the back end, Korma is simply, you know, writing out joins. It's not doing anything particularly special here. For the most part, it's just writing out the joins so that you don't have to. So this isn't an ORM in the large hibernate sense where it's doing all this crazy magic on the back end. For the most part, it's just helping you write queries more efficiently, right? At the end, it's just writing very simple SQL. I think the advantage, or rather the power of Korma, though, is not so much in just the abstraction. It's nice to be able to write it, you know, succinctly and cleanly and clearly. But I think the real power of Korma comes in the fact that, much like Cascalog, it is entirely composable, right? You can, in this case, instead of using the select macro, you select star, and then start building up a query. And then you add more to the query, and then you add more to the query. All you're doing here is actually manipulating a map. And what Korma really is, if you want to break it down into its constituent pieces, is actually a SQL generation engine, right? And then a nice way of writing out the maps that go to it. That's all it is. Now, when you start thinking of libraries in that way, where you always have sort of this one thing that can take basically any arbitrary map that you create for it and then generate SQL out of it, this allows you to literally completely replace my syntax. The API I've provided here. You could, you know, you don't like select, write some other thing that creates, you know, a map that represents a select query. You wouldn't actually have to rewrite all that SQL generation stuff. So this enables you to actually add to Korma in interesting ways. So I provide a relatively simple set of relationships. But you could imagine actually creating a property or a method, rather, or a function for a def entity that creates all the relationships for just a chain. Let's say you're constantly using one entity and you want, you know, something that's like 8 levels nested, right? And you don't want to constantly write those joins out. As a matter of fact, you may do that all the time, so you don't want to write, you know, like I've done here, where you're writing essentially functions to add that each time. You could actually add it to Korma itself. You could go up here, right, and in your def entity say, you know, chained address to state to whatever else you may have, to zip code to blah, blah, blah. And then Korma can then, you know, you could then use that in widths and enable yourself to essentially write out all those joins for you. So it's a really extensible way of dealing with SQL in general. Another thing that I wanted to make sure was that it was flexible in a way that wasn't annoying, right? So Hibernate has gotten a lot better over the years, but I remember the first few versions, it was like pages and pages and pages of XML files where you had to configure everything. While you do need to do that at some times, right? You shouldn't always have to do that. There's value in the things that Ruby on Rails presented, which is this, you know, this notion of convention over customization. But you need to be able to sort of get out of it if you need to. So for example, I used to work on a massive project that had a wine database for literally millions upon millions of wines, and everything you could ever want to know about them. But that database was built up over many years by many different companies, and so we had a wine table, an underscore wine table, an underscore underscore wine table, right? We had all these weird sort of names, and none of the keys would match. And so another thing that I wanted to make sure when I wrote Korma, that it was built for real-world stuff, right? I don't make assumptions, and when I do make assumptions, you can override them. And that's I think, an important part of being really useful in this space. So I mean, there's lots of interesting things here. It's actually really small. So if you want to see how you might write a SQL generating engine that runs off of maps, take a look at the source. Yeah, I don't want to take up any more time. So if you have any questions, if I have time. Yeah.
Do you do your joins all in one swipe, or do you, like in Hibernate, you could do a cascading, so like the first layer, and then do the second level of interaction lazily, or on demand? Do you do that, or no?
So by default, my has many relationship, right? Because that can be a multiplicative set as you go down. You don't want to do that all really in one query most of the time, and you want to do it lazily, like you said. My has many does exactly that. And you could write very, very similar things that do that. There's the notion of a post query, essentially, where you say, oh, do this with the the primary key of this other thing, and it makes it easy, actually, to add, if you don't like what I've done, even add more complex ways of doing it.
About how much code is dedicated to differences between syntax in different backend databases?
Well, not a ton right now. And I'm sure there are bugs in this because I only use a few databases. I have not tested against a lot of them. So once people start using it, I'll start sussing that out. Now, to be clear though, it does use JDBC on the back end, right? So some of that is handled purely by JDBC, somebody who's done this for a lot longer than I have, and I don't have to, I know that they're correct. I don't have to worry so much about it. Just like parameterized queries as an example, right? All of that is to make sure it's safe. I don't want to touch that as much as I can. I should also mention you can actually get the SQL out of this and do stuff with it if you want. So you don't actually have to use it to execute. You don't even like that. You could, if you're working in another project, you could actually use Clojure to generate your queries for that other project in a different language, and